What if you could build things one single atom at a time? It sounds like something straight out of science fiction, right? But it's not. It's the very real, very incredible world of nanotechnology. So today, we're going to dive into this amazing science, all the way from the super strong materials in your gadgets to tiny little robots that could, one day, perform surgery from inside your body. Let's get into it.
First things first, just how small are we talking when we say nano? Well, let's try to get some perspective. A single strand of your hair, that's about 80,000 nanometers wide. A plain old sheet of paper is 100,000. We are talking about a scale so ridiculously tiny, it's almost impossible to wrap your head around. And that's exactly where the magic happens, because at that scale, the basic rules of the physical world start to get a little weird.
So at its heart, nanotechnology is all about building and controlling stuff at the atomic and molecular level. But here's where it gets really cool. When you shrink things down that small, their fundamental properties can change completely. I mean, gold, for instance, stops looking gold. It can appear red or even green. Materials can suddenly become unbelievably strong, incredibly conductive, or react in ways they just don't at a larger scale. This right here is the source of nanotechnology's power.
And the first place we really see this power at work, it's in the technology that we're using every single day. Nanotechnology is kind of the hidden engine that's making all our devices smarter, faster, and way more powerful.
I mean, just think about how our electronics, our phones, our laptops just keep getting smaller and more powerful year after year. That's nanotechnology doing its thing. By building computer components on the nanoscale, engineers can cram way more power into much smaller spaces, completely blowing past the old limits of what we thought was possible.
Let's just do a quick comparison. For decades, right, silicon has been the king of electronics. It's the standard. But look what happens when we swap it out for a nanomaterial like graphene or carbon nanotubes. We go from just standard performance to components that are way faster and much more energy efficient. And why? Because electrons can just zip through a sheet of graphene that's only one atom thick with almost zero resistance. So the big takeaway here isn't just that things are getting smaller, it's that they are getting fundamentally better.
And you know, this isn't just about high-tech computer chips. Nanotech is probably in things you use today. Think about those scratch-resistant coatings on your glasses or water-repellent jackets. At the nanoscale, that fabric is structured so water just can't grab onto it. It beads up and rolls right off. We see the same ideas at work in self-cleaning windows, stain-resistant clothes, and even in sunscreens that give you way better UV protection. It's like this invisible revolution happening all around us.
And it doesn't stop there. The technology is always evolving. We're moving past simple coatings and into creating actual smart fabrics. Imagine wearing a shirt with fibers that are engineered to actively regulate your body temperature, pull sweat away from your skin, and can even fight off germs. This is totally changing athletic wear, and it's also creating brand new possibilities for things like hospital gowns and bandages.
And speaking of medicine, this is where nanotechnology's impact gets truly profound. I mean, it becomes deeply personal. It's helping us solve some of the absolute biggest challenges in modern healthcare.
So here's a basic problem that doctors have been dealing with for, well, forever. When you take a medicine, like a pill, it usually goes everywhere in your body. And that causes side effects because it hits healthy cells, not just the ones you're trying to treat. The biggest challenge has always been about precision.
This is where nanomedicine comes in, with just a brilliant solution. It's an incredibly precise process. So first, you load up these tiny nanoparticles with medication. Then, and this is the key part, they are engineered to act like tiny guided missiles that seek out only specific targets, like cancer cells. They travel through the body, find their target, and deliver the drug right where it's needed, leaving all the surrounding healthy tissue alone.
And the results of being so precise? Well, they're dramatic. This chart tells the whole story. You can see that treatment efficacy, how well the drug actually works, is way higher with nanodelivery. And at the exact same time, look at the bar for side effects. It's way, way lower. This isn't just a small improvement. It's a total game changer for how we can treat diseases.
And the list of applications just keeps growing. Nanotechnology is giving us diagnostic tools that are so sensitive, they can spot diseases at their absolute earliest stages, when they're easiest to treat. It's being used to create these incredible scaffolds that literally guide our own bodies to regrow and repair tissue. And it's making medical implants that are stronger, last longer, and are way more compatible with the human body.
Okay, so from the personal scale of our own bodies, let's zoom all the way out now to the global scale. Because nanotechnology is also becoming an absolutely critical tool for tackling some of our planet's biggest environmental challenges.
And its impact really shines across three key areas that are vital for a sustainable future:
how we generate and store clean energy, how we get clean water, and how we make sure we have enough food for everyone.
So in energy, for instance, nanomaterials are making solar panels much more efficient at capturing sunlight. And, just as important, they're completely revolutionizing energy storage. We're talking about advanced nanobatteries and supercapacitors that can hold more charge and last longer, which is really the missing piece of the puzzle for making renewable energy reliable 24/7.
When it comes to water, the impact is just massive. Nanofilters can work on such a fine scale that they can pull out the tiniest, most difficult contaminants, everything from viruses to heavy metals from industrial pollution. This tech offers a really powerful and potentially affordable way to fight global water scarcity and bring safe drinking water to millions of people. And then there's agriculture, where nanotech is helping us build a smarter, more resilient food system. We can use it to boost the nutrients in food or create packaging that keeps food fresh for way longer, which cuts down on waste. It also allows for the super-targeted delivery of fertilizers directly to a plant's roots, so farmers can use a lot less, which dramatically reduces pollution and runoff into our environment.
So, we've seen how nanotechnology is changing our world right now, today. But what about tomorrow? Let's wrap up by taking a look at the next frontier, because this is where things start to feel like pure science fiction.
Okay, one huge area is something called nano-electromechanical systems, or NEMS. And believe it or not, you actually have one in your pocket. The tiny little accelerometer in your phone that detects when you tilt it, that's a NEMS. Now imagine applying that same idea on a bigger scale. Nanotechnology is creating these ultra-light yet incredibly strong materials that are perfect for building more efficient spacecraft, or for making super-sensitive instruments to explore deep space.
But the most futuristic, the most mind-bending application of all comes when you smash nanotechnology and robotics together. And that gives us a whole new field, nanorobotics. The science of building microscopic, programmable machines. Basically, tiny robots built molecule by molecule.
This quote really says it all. I mean, just imagine it. Tiny robots swimming through your bloodstream to hunt down diseases, performing surgery without ever making a cut, or repairing damaged cells one by one. I know, it sounds like something from a movie, but this is the future that scientists are actively working on building right now. Which brings us right to our final thought. Nanotechnology is giving humanity a level of control over the physical world that we've just never had before. It's the power to design and build from the ground up, starting with the smallest possible pieces. So the real question isn't just about what we can build, but with this incredible new power, what kind of future are we going to choose to create?